Now we're going to need to calculate a molar mass. This is the mass of 1 mole in grams. So it's going to be equal to our numerical value of our average atomic mass. We're going to get this from the periodic table. So for example, a mole of carbon is 12.01 grams. A mole of magnesium is 24.31 grams. A mole of copper, 63.55 grams. Let me show you where that comes from. So if we're looking at carbon on the periodic table, the average atomic mass here, 12.01, that's the molar mass. A mole of magnesium is 24.31 grams. That's your number that you find on your periodic table. A mole of copper, 63.55 grams. Again, periodic table here. Now you're going to hear other terms, molecular mass or molecular weight, formula mass or formula weight, and molar mass. They're all the same number. The difference is in the unit, okay? But again, the same, you calculate the same way, it's going to be the exact same number. So don't let the terms throw you off. Alright, so the mass in grams of 1 mole is equal to the sum of your atomic masses if we're talking about a compound. For example, if we find the mass of sodium chloride, which is 1 sodium, 1 Na, and 1 chlorine. So 1 mole of sodium from the periodic table is 22.99 grams. A mole of chlorine is 35.45 grams. So if we add those together, we get a total mass of 58.44 grams. So let's look at a couple of examples of this. So if we find the molar mass for water, we need the formula first of all for water, so it's H2O. Now what we're going to do, we're going to follow this process, and we're going to use this process for several things. We're going to start by listing the elements in our compound. So for water, we have hydrogen and we have oxygen. Okay, so these are coming from our formula here. Then we're going to list our number of moles. Now the number of moles is your subscript. So for hydrogen, it's 2. Okay, and for oxygen, it's 1. Then we're going to get the molar mass from our periodic table. So for hydrogen, that's 1.008. For oxygen, that's 16. Now we're going to multiply these because we have 2 hydrogens. Each one has a mass of 1.008. So hydrogen's going to contribute a total of 2.016 grams, and the oxygen is going to contribute 16 grams. Now we're going to add those together to get a molar mass of 18.016 grams per mole as the molar mass for water. Now let's look at another example. This is calcium phosphate. So first of all, we need the formula. So this is an ionic compound. We have to look at the charges to write the formula. When you do that, calcium's +2, phosphate's -3. So the formula is Ca3PO42. Now we're going to list our elements. Okay, so our elements here are calcium, phosphorus, and oxygen. Now we're going to list how many. Alright, those are going to be our subscripts. So for calcium we have 3. Now remember that to count when you have parentheses, this phosphate means that there's 2 PO4s. So that means there's a total of 2 phosphorus atoms and a total of 8, 2 times 4 is 8, oxygen atoms. So make sure you multiply each thing in the parentheses by what's on the outside. Now we're going to get the masses from the periodic table. So for calcium, it's 40.08. Phosphorus is 30.97. Oxygen is 16. Now we're going to multiply each of these. So we get 120.24, 61.94, and 128. Now we're going to add all of these together, and that is going to give us a molar mass of 310.18 grams per mole for calcium phosphate. Now, how are we going to use this?